Today we're going to be diving deep into AWS Route 53 Resolver, one of AWS' most powerful but often misunderstood DNS services. Think of Route 53 Resolver as the intelligent traffic director for your DNS queries. It sits between your application and the DNS servers they need to reach, making smart decisions about where each query would go. Whether you're building a hybrid cloud architecture, connecting multiple VPCs, or just trying to understand how DNS works in AWS, this presentation will give you the practical knowledge. Let's start with what Route 53 Resolver actually does. Every VPC in AWS automatically gets DNS resolution capabilities, but the default setup is quite limited. Route 53 Resolver extends these capabilities dramatically. It allows you to create custom DNS resolution path, forward queries to on-premise DNS server, and even receive DNS queries from external networks. The key insight here is that Resolver acts as a bridge. It connects your AWS environment with external DNS infrastructure seamlessly. The diagram here shows the heart of how Route 53 Resolver works. Let me walk you through it. When a client makes a DNS query, sorry about that. When a client makes a DNS query, it first hits the Route 53 Resolver service. The resolver then makes a decision based on the query type and your configured rules. For local VPC resources, it uses the built-in VPC DNS. For extended external domains, it can go to the public DNS servers, but here's where it gets interesting. You can configure outbound endpoints to forward specific domains to your on-premise DNS servers. The inbound endpoints work in reverse. They allow external networks to query your AWS DNS resources. The inbound endpoints work in reverse. They allow external networks to query your AWS DNS resources. This is crucial for hybrid architecture where on-premises systems need to resolve AWS resource names. This is where Route 53 Resolver really shines in hybrid cloud scenario. Let me explain this architecture because it's probably the most common use case you'll encounter. On the AWS side, you have your VPC and EC2 instances and other resources. The Route 53 Resolver sits in the middle between with both inbound and outbound endpoints configured. The outbound endpoints forwards queries from AWS to your corporate DNS server over an encrypted tunnel, either VPN or Direct Connect. This means when your AWS applications need to resolve internal company domain names, they get routed to the right place. The inbound endpoint does the opposite. It receives queries from your on-premise network and resolve them using AWS DNS or Route 53 private hosted zones. This is essential when your internal system need to talk to AWS resources using DNS names. One of the most powerful features of Route 53 Resolver is its ability to work across VPCs and even AWS accounts. This diagram shows a common enterprise pattern. You might have application in one account that need to resolve services in another account. There's VPC A and VPC B. Or you might have a shared services account that provides centralized DNS management for multiple other accounts. The key is AWS Resource Access Manager. We had a lecture about that. You can create resolver rules in one account and share them with other accounts. This enables centralized DNS policy management while maintaining account boundaries. So here we see account B and account A. There is basically we have a shared VPC resolver that allows you to share that resolver to a central DNS, and basically using Resource Access Manager you can share this resolver endpoints, and it can be used from the VPC to basically find resources in the central DNS, and we do have resolver rules as well. So the key components, let's talk about the key components, because understanding these is crucial for successful implementation. Resolver endpoints are the network interfaces that actually handle DNS traffic. You have inbound endpoints that receive queries from external networks, and outbound endpoints that forwards queries to external DNS servers. Resolver rules define the logic, which domain get forwarded where. You can create forwarding rules that send specific domains to specific DNS servers, or system rules that use AWS built-in resolution. Query logging captures all the DNS activity, which is invaluable for troubleshooting and security monitoring. You can send those to CloudWatch, S3, or Kinesis. Before we dive into the CLI commands, let's talk about what you need to have in place. These prerequisites are important because missing any of them will cause your setup to fail. First, you need proper VPC setup with subnets in multiple availability zones. Route 53 resolver endpoints require at least 2 IP addresses in different availability zones for high availabilities. Security group are crucial. They control access to resolver endpoints. You'll need to allow DNS traffic on port 53 for both TCP and UDP. If you are setting up hybrid connectivity, if you need either VPN or direct connect already configured, the resolver endpoints need to be able to reach your on-premise DNS servers. Finally, make sure you have the necessary IAM permissions. You'll need the Route 53 resolver permission along with the usual EC2 and VPC permissions. Let's start with the practical implementation. Security groups are the foundation of your resolver endpoint security. So we need to get this right. The first command creates a security group specifically for our resolver endpoints. I always use descriptive names so that we know that this is for the resolver. Then we add the ingress rules, which allows UDP and TCP port 53. So we need both protocols. I'm using the security group itself as the source. This basically as the source. This is a common pattern that allows resources with the same security groups to communicate with each other. In production, you might want to be more specific about the source IP ranges, especially if you're receiving queries from specific on-premise networks. Now let's create the outbound and outbound resolver. This is what you'll use to forward DNS queries from your VPC to external DNS servers, typically your on-premise DNS infrastructure. The key parameter here are the outbound direction and the IP addresses. You must specify at least 2 IP addresses in different availability zones. This ensures high availability if one availability zone goes down. I like to assign specific IP addresses rather than letting AWS choose randomly. This makes troubleshooting easier and gives you predictable endpoints that configure in your on-premise systems. The response shows basically will show you expected responses resolver endpoint, the resolver endpoint ID, which you'll need for creating resolver rules. Also notice the status is creating will take creating and then operational 2 to 5 minutes. Inbound endpoints serve the opposite purpose. They receive DNS queries from external networks and resolve them using AWS DNS services. The command structure is almost identical to the outbound endpoint, but with a direction inbound. These IP addresses are what you your on-premise DNS server will forward queries to when they need to resolve AWS resources. One important consideration is that these IP addresses need to be reachable from your on-premise network. Make sure your VPN or direct connect routing is configured to allow traffic to these subnet ranges. In many enterprise setups, you'll configure these IP addresses as forwarder in your on-premise DNS server for the domain like aws.company.com. This is create resolver rules. This is where the magic happens. Resolver rules define which domains get forwarded where. The rule I'm showing here forwards all queries for corp.internal to specific on-premise DNS servers. The rule type forward means we are sending queries to the target IP addresses. You can specify multiple target IP addresses. If the first one doesn't respond, it tries the next one. The domain name supports wildcard. It could match like asterisk.corp.internal. The domain name supports wildcard. So this is incredibly powerful for organizations for organizing your DNS namespace. Notice the resolver endpoint. This must be an outbound endpoint. The rule essentially says when someone queries corp.internal, use this outbound endpoint to forward the DNS query to on-premise DNS servers. Creating a rule isn't enough. You have to associate it with the VPCs for it to take effect. This is actually a powerful feature because it gives you granular control over which VPCs use which rules. You might have different VPCs that need different DNS resolution behavior. For example, your production VPC might forward internal domains to production DNS servers, while your development VPC forwards to development DNS servers. The association creates a link between the rule and the VPC. Once this is in place, any DNS query from resources in that VPC will be evaluated against this rule. You can associate the same rule with multiple VPCs, and you can associate multiple rules with the same VPC. The resolver evaluates rule based on specificity. More specific domain matches text precedence. So the resolver rule, we created the resolver rule, then we associate the resolver with the VPC that it will utilize it. Query logging is absolutely essential for troubleshooting and security monitoring. First, you create a query log configuration, create resolver query and config that specify where the logs should go. and this is the ARN. Destination ARN is the log group that we called Route 53 resolver. CloudWatch logs is the most common destination, but you can also use S3 or Kinesis Firehose. Then you associate the log configuration with the resolver with your VPC. Once this is active, you'll see every DNS query that goes through the resolver, along with the response and timing information. The logs include source IP, query name, query type, response code, and resolver endpoints used. This data is invaluable for understanding DNS patterns and diagnosing issues. So we created the AWS resolver config, and we specify the destination ARN for the Route 53. We'll call it here Route 53 resolver. It's specifically for that purpose. And then it's going to return the config ID. Then you can basically associate the config ID that you received with the resource ID, which is the VPC. The wildcard rule is incredibly powerful. It matches all subdomains under a parent domain. This is perfect for corporate environments where you have many applications under a single domain. So here we're forwarding wildcard.corp.internal rule forward, and then we're forwarding it to multiple target IPs and on-premise. System rules are another important concept. When you create a system rule for a domain, it tells the resolver to use AWS built-in DNS resolution instead of forwarding to external servers. This is useful for ensuring AWS service domains always resolve correctly. So make sure that basically we use the system rule type system. We're going to send all Amazon AWS.com to the system, the AWS system rule. So this way you make sure that AWS services are never interrupted. One of the most powerful enterprise features is the ability to share resolver rule across AWS account using AWS Resource Access Manager. I had a lecture on Resource Access Manager. This enables centralized DNS management. You can create all your resolver rules in a shared services account and then share them with other accounts using the Resource Access Manager. This ensures consistency and reduces management overhead. The shared rules appear in the target account as if they are locally configured. This is perfect for large organizations with multiple AWS accounts that need consistent DNS behavior. You can share with specific account IDs or even with your entire AWS organization. The permission model is flexible and secure. When things go wrong with DNS, you need a systematic approach to troubleshoot this flow. This flowchart shows the process. First, always check the resolver endpoint status to see if it's operational. If it's not, then that's your problem right there. If it's creating and updating, then wait for completion. If it's operational, check the resolver rule to see if the rules are missing, a rule is missing, create that rule. If the rule is active, then check the VPC association to make sure that there is an association to that VPC that, sorry about that. Then check network connectivity. Can your resolver endpoints actually reach the target DNS server? Use VPC flow logs or try connecting from an AC2 instance in the same subnet. Finally, dive into the query logs. They'll show you exactly what queries are being made and what responses are being returned. Here are the AWS CLI commands to use more often when troubleshooting Route 53. The get resolver endpoint command shows you detailed status information, including the IP addresses and current operational state. If there are any issue, they'll usually be reflected in this status message. List the resolver rules is crucial in verifying that your rules are actually associated with VPCs where you expect them to be. From EC2 side, dig and NSLOOKUP will help you kind of understand what's going on. You can test DNS resolution directly against your resolver endpoint IP addresses to verify they're working correctly. Don't forget about the CloudWatch logs. The CloudWatch logs will help you also troubleshoot the issue that you are having. Hybrid cloud DNS is the most common use case, real world use case. Companies migrating to AWS applications to resolve internal company domain names, and they need their on-premise systems to resolve AWS resource names. Multi-account enterprise often use centralized DNS management. They create resolver rule in a shared service account and share them across all their other accounts for consistent DNS behavior. Acquisition integration is another interesting use case. When companies acquire other companies, they often need to integrate DNS names quickly. Route 53 resolver makes this much easier than traditional DNS. Development and testing environment benefit from isolated DNS resolution. You can have different resolver rules for dev, test, and prod environment, ensuring they resolve to the appropriate resources. Let's talk about costs. The Route 53 resolver isn't free, and the costs can add up quickly. Each resolver endpoint costs about $125 per month, regardless of how much traffic it handles. So if you need both inbound and outbound endpoints, that's $250 a month. DNS queries are also charged separately, about 40 cents per million queries. For most organizations, the endpoint costs are much higher than the query costs. The best practice is to consolidate where possible. Instead of creating resolver endpoints in every VPC, consider using VPC peering or transit gateway to share endpoints across multiple VPCs. Also, be strategic about which domains you forward. Don't forward everything, only forward the domains that actually need to be resolved by on-premise DNS servers. Security is crucial when you're bridging DNS between AWS and on-premise. Always use the principle of least privilege in your security groups. Only allow DNS traffic from the sources that actually need it. Consider using AWS security groups referencing instead of broad IP ranges. Enable query logging and monitor regularly. DNS can be a vector for data exfiltration, so you want to know what queries are being made and from where. Use DNS filtering and threat detection. AWS Guard Duty can identify malicious DNS activity, and you can implement DNS filtering using tools like Amazon Route 53 Application Recovery Controller. Consider DNS over HTTPS or DNS over TLS for sensitive environment. While Route 53 resolvers doesn't natively support these, you can implement them in your own architecture. Now that we talked about Route 53, start with simple proof of concept in the development environment. Create basic outbound endpoint and rule to forward a test domain to an external DNS server. This will help you understand the concepts without risking production systems. Plan your DNS namespace carefully before implementing in production. Think about how you want to organize your domains and which ones need to be forwarded where. Implement monitoring and alerting from day one. Set up CloudWatch alarms for resolver endpoint health and query volume. Create dashboard to visualize your DNS traffic patterns. Finally, document everything. DNS configuration can be complex, and you'll thank yourself later for having good documentation of your resolver. Thank you for your time today. I appreciate it.